Welcome. In this video, we are going to look at magnetic energy density. Magnetic energy density is magnetic energy divided by volume. So let's write that down. Magnetic energy density is equal to magnetic energy divided by volume. We can use the variable U sub B for magnetic energy density. We can find the relation between magnetic energy and magnetic field using the energy of an inductor. The energy of an inductor is equal to 1/2 Li squared, where L is the inductance of the inductor and I is the current through the inductor. Now the inductance of a long solenoid is L is equal to mu 0 n squared A times L. And so L is the length of the solenoid, A is the cross-section area, N is the number of turns per length, and mu 0 is the permeability. We also know the magnetic field due to a solenoid is mu 0 n times I. And so current I is magnetic field divided by mu 0 times n. We can make these substitutions and we find energy is 1/2 times L, which is mu 0 n squared A times L, and then we have the quantity B divided by mu 0 times n, and we're going to square that. Expanding gives us 1/2. We've got mu 0 n squared A L, and then B squared over mu 0 squared n squared. So we can cancel the n squareds and we can cancel one of the mu 0s. And we get 1/2. We're going to have A L B squared over mu 0. And now notice that A times L is equal to volume. So if we divide both sides by A times L and call that volume, we have energy per volume is equal to 1/2 mu 0s times B squared. And so we have U sub B is equal to 1/2 mu 0 times B squared. And that is for values at an instant in time. I hope you found this helpful. Let me know in the comments section if you have any questions. Thank you for watching, and I'll see you in the next one.